Alright, if you meet a question like this, which of the following atoms contains the highest number of electrons in the outermost shell? Which of the following atoms contains the highest number of electrons in the outermost shell? A. Oxygen, having atomic number 8. B. Neon, having atomic number 10. C. Phosphorus, having atomic number 15. And D. Potassium, having atomic number 19. Alright, for you to be able to answer this question correctly, you need to have a good knowledge of electronic configuration. And for you to do that, you have to either master the SPDF method of electronic configuration or the KLMNO method of electronic configuration. Alright, that of SPDF corresponds to Aufbau principle. Aufbau principle. The principle is of the view that orbitals of lesser energy must fill completely first before orbitals of higher energy. Orbitals of lesser energy must fill completely first. Aufbau principle is of the view that orbitals of lesser energy must fill completely first before orbitals of higher energy. Alright, for you to master that, you have to have a building block techniques. I have a column here. Number it 1 to 7. One, 2, 3, 4, 5, 6, and then 7. Start from the first line, bring it down again to the last. Number it 2, 3, 4, 5, 6, 7. Start from the second line, bring it down again to the last. Number it 3, 4, 5, 6, 7. Start from the fourth line to the down again. Number it 4, 5, 6, 7. Alright. If you have done that, all the first column, put it X throughout. The second row, put it P throughout. To the third, put it D. And to the last, put it F. Having done that, you fill diagonally. You fill diagonally. Diagonally. This diagonally means that you first of all fill 1s. After the 1s, you fill 2s. After 2s, you go back again, starting from the bottom, that is 2p. Diagonally 2p. After 2p you have 3x. After 3s, from here you go back again, starting diagonally, that is 3p to 4s. After that, diagonally again, you have 3D. After 3D, you have 4p. After 4p, you have 5x. To be continued. Now, from the question, if I want to fill the electronic configuration for oxygen, I'm going to fill the electronic configuration for oxygen using this method as I have written. So, oxygen has atomic number 8, like they gave us in the question. Oxygen 8. So I have, starting from the beginning, there is 1s, that is the first one, and x, all these letters, x carry maximum electron of 2. You can put any other letter, any other number after 2. That is, it can have 1, it can have 2, but it can't have 3. 2 is the maximum number of electrons that s can carry. P can carry maximum electron of 6. It can't carry more than 6. You can put 1, 2, 3, 4, 5, but it can't carry 6. D carry maximum electron of 10, and F carry maximum electron of 14. So for oxygen, the first here will carry 2. You go to the next shell. The next subshell, which is 2x, we carry 2 as well, because it can't carry more than that. Go to the next subshell. 2p. 2p we carry, how many have we put? We have already put 4. Remaining 4. So p can still carry 4. This is the electronic configuration for oxygen. Do the same thing for neon. Having atomic number s, we have 1s to 2s to 2p6. That is the electronic configuration for neon. You have for phosphorus, which is 15, 1s to 2s to 2p6. You go to the next subshell, which is 3x2. You go to the next subshell, which is 3p. How many have we put? We already put 12. Remaining how many? 3 to get complete. This is for phosphorus. For potassium, we have 19. 19 is 1s to 2s2. Follow the same pattern. 2p6, 3x2, 3p6. How many have we put? We already put 18. If you calculate 2, 4, 10, 12, 18. 4x is the next we are going to fill for s. So 4s1 now. This is the electronic configuration for potassium. Now, which one have highest number of electron in their atomos shell? Check out for oxygen. This is the last shell. The principal quantum number, the highest number here is 2. So since the 2 of them are the last shell, add their numbers together, you have 6. Check for this neon. This 2 is the highest, and so add the 2 numbers they have, you have 8. Check this one. 3 is the highest number, principal quantum number here, so you add the 2 electrons, you are going to have 5. Check for this one. 4 is the highest number of electrons. There's no other 4 here. The highest number is 4. So the last shell has 1 electron. So from all these, which of them has highest number of electrons? So it is what? Neon. And so neon is the answer, and option B is correct. If you choose not to use this method, you can as well use KLMN method of electronic configuration. And in this method, you either use cycle to represent it. All you just need to know is to know that maximum number of electrons that will be in any shell is represented by the formula 2Na squared. So therefore, for K shell, the maximum number of electrons that will be there, K represents 1, as they are written here, KMN KLMN to be continued. This represents 1, this 2, 3, 4, 5 to be continued. So for number 1 shell, how many number of electrons will it contain? To use this formula, you are going to have, anywhere you see n, you put 1 squared. 1 times 1 is 1. 2 times 1 is equals to 2. So the maximum number of electrons that will be in K shell is 2. The maximum number of electrons that will be in L shell is 8. Follow the same pattern. And how many times each of these shell can still break is represented by the formula N squared. The formula N squared. Use this formula to know how many times each of these shell can still break. This K, will it have a subshell? Let us check. You say 1 squared. 1 times 1 is equal to 1. So K shell remains the same. It does not break. While L shell, let us check if it can break, if it can have subshell. So you have 2 raised to power 2. So 2 times 2 is equal to 4. That means L shell can still break into 4 subshells. And those 4 subshells, it means that we are going to be having 8 till 4 shells are completed before you get to M shell. So for what the question we have here, we are only going to be using K and L only, because that's where it will stop. So if we are using this method to fill this electronic configuration, let us fill for oxygen. Oxygen having atomic number 8. So you fill the innermost shell electron will carry how many? 2, which is the K shell. You go to the next one, because this cannot carry again. How many is this place supposed to carry? It's supposed to carry 8 electrons. So but how many do we have for oxygen? We have 8. So we have put 2 already, remaining 6. So put 1, you pair it. So 8 is completed here. If you count it, this is 1, 2, 3, 4, 5, 6, 7, 8 completed. So because it's completed, this is the electronic configuration for oxygen. Do the same for neon. You're going to have this for neon. Do the same thing for phosphorus, 15. The innermost shell will carry 2, followed by the one that will carry 8. Then followed by how many that is remaining? Is 5 that is remaining. So 5 is the outermost shell. So you do the same thing for potassium. Potassium having 19. Do the electronic configuration. You have innermost one carry. The next one will carry 8. Next one will also carry 8. Next one will carry 1. Next one will still carry 8, because I want to put 19. How many have I put? 18. Put the last shell. The last shell will carry only 1. So check the